our COP26 programme will provide the direction needed to close technology gaps and define a clear path to net zero. So, what's going on? Our virtual platform allows you to be as interactive as you like over the next 3 days. We encourage you to get involved, have a voice, and you can do this in a few ways. You can join a live event and chat to fellow attendees, or you can visit the exhibition booths. We have 4 exciting live events planned over the next 3 days, broadcast live from Glasgow. You can find the live events on the main stage, which you can access on the left-hand side of your screen. When we don't have a live event broadcasting, head on over to the exhibition. The exhibition will be open throughout the 3 days, and the technology developers will be available to chat to you on Tuesday, the 2nd of November, between 10 a.m. and 1 p.m, and again on Wednesday, the 3rd of November, from 2 p.m. to 4 p.m. I really encourage you to meet these super people behind the projects. They're creating game-changing technology to assist us in the energy transition. So make sure to pop into their virtual booths, say hi, ask questions, and be curious. Over the course of the 3 days, we'll also be joined by 10 other technology and research centres from the UK, USA, Canada, Australia, Brazil, and the Netherlands, who will each present their net zero vision for their basin during the Technology Driving Transition Global Summit that we will be hosting. We'll look at technology priorities and gaps across various regions and highlight areas where innovation can be utilised to drive the transition of mature hydrocarbon basins to an integrated net zero energy future. The first live event is up shortly, so keep an eye out on the main stage. Tomorrow afternoon at 1:30 p.m, we host our Clean Energy Pitch Battle, where we get 10 companies that are going to go head-to-head live, competing to be crowned the champion of the Clean Energy Pitch Battle. This will be a very exciting event, and we can't wait to see how everyone gets on. Good luck to all of the participants. And now lastly, a little bit of housekeeping from me. We really would like you to get involved. Use the chat function, meet somebody new, and participate in the polls, which are on the right-hand side of your screen under the poll tab. If you have any questions throughout the day, head to the support booth within the exhibition, and a member of our team will be happy to assist you. If you miss a live event, don't worry. It will be available on demand via the Hop-In platform once the session finishes. And you'll also find it on the Net Zero Technology Centre website after the virtual event closes on the 3rd of November. So, I hope I get to meet some of you soon. I hope you find your voice and get to participate. This is our chance. This is COP26. Let's make it a memorable one. Thank you.
Hello and welcome. Welcome to our Technology Driving Transition International Summit, live from Glasgow for COP26. And we're streaming live here from the Technology Innovation Centre at the Strathclyde University. And I'm glad that we have people in the room. We missed you in the past couple of years, but we also have plenty of people following us through Hop-In and on LinkedIn, and acknowledging them, and glad that you can be with us today. So it's happening. COP26 is finally happening. And I don't know about you, but I'm quite excited. You know, there's a sense of anticipation, there's a sense of hope and excitement. And so we all hope that COP26 will deliver what we want it to deliver. There's some concern as well, of course, like always in these kind of situations. And I think we'll have to live through it and see what comes out of it in the next couple of weeks, and try to influence in it as much as we can. And for our side, that influence comes in the shape of technology and technology innovation. So today is about technology. And technology is essential to deliver the net zero outcome that we hope to see. And technology innovation in particular. But to explain why that is so important, I'm glad to have Colette Hohen, the CEO of the Net Zero Technology Centre, to give us a bit of an explanation why we're here. What are we trying to achieve in these 3 days? Colette.
Super, thank you. Do I need that? I'm just guessing I might for the stream. Good afternoon, lovely to see you all. And really it'll be very brief because you're going to listen to a lot of people today who will be much better placed to guide you on the journey that we're about to go on. But as Lucas said, innovation is critical to our overall global goal of a net zero future. And COP26, we've heard all sorts of, dire warnings as people came into today. But actually, I hope that today and the next 2 or 3 days where we're together and we're bringing these really great research organizations together, that we're going to be a bit of a moment of positivity and hope. Because I actually think when you bring a whole group together to look at what the technical solutions could be and to look for ways to make a difference, for us to address our emissions, to get down to those targets by 2030, 2035, not 2050, but sooner. And particularly when we represent an industry that is a high carbon emitting industry, like the oil and gas industry, I think it's super important that organisations like ours can come together and make a difference. So this is about 10 fabulous research organisations coming together from around the world, from Canada, the US, Brazil, Australia, the Netherlands, the UK, all working together to understand what are the technology barriers, what are the technology opportunities, how could we work together to accelerate our ability to deliver net zero. Me, I find that really exciting. That's what this is all about. And I'm super delighted to also say that to open this event, we have Cabinet Secretary Michael Matheson with us, who is Cabinet Secretary for Net Zero, Transportation and Energy. So thank you very much. I'm going to hand over to Michael.
Thank you very much, and good afternoon, everyone. For those who are visiting Glasgow and Scotland, a very warm welcome. And to those who are online, hopefully you'll have an opportunity to visit Glasgow and Scotland at some point in the future. But look, I'm particularly pleased to be able to join you here for the opening of this summit over the course of the next 3 days. When I became the Cabinet Secretary for Net Zero back in May, I remember fondly sitting in Butte House when the First Minister said she was appointing me to this post, and I said, well, what exactly do you want me to do with it? And she said, well, your job is to get us from here to net zero by 2045. But there's no pressure. We have to get our emissions down to 75% between now and 2030. So there's a significant challenge there, but it's not just a challenge which we have here in Scotland. There's a significant challenge here globally. And we need all of the expertise, talent and skills in order to help to support us in delivering that transition. We've been blessed in Scotland over the years by having fantastic skills and expertise in the oil and gas sector. The northeast of Scotland is not just a centre of expertise in Scotland or the UK, but globally it is recognised as a centre of expertise, talent and knowledge in the oil and gas sector. And everyone within the oil and gas sector knows that between now and 2050, and even beyond 2050, we will still require to make use of oil and gas in one shape or form. So the real challenge from a policymaker's point of view is how do you ensure that we continue to make use of oil and gas between now and 2030, 2045, 2050 and beyond in a way which is compatible with becoming a net zero society in Scotland by 2045. And the reality is that we probably don't have a clear pathway on how we will achieve that, because some of the technology which will be necessary to help to support that transition has still to be developed and to be tested and to be utilised. So what's the Scottish Government's ambitions? What are my ambitions as the Minister responsible for this area of policy? If I was being frank with you in the oil and gas sector, and I'm saying something to you that I've already said to the oil and gas sector, is that, well, COP26 is taking place in Glasgow. If I was to ask the thousands of people who are standing outside demonstrating, is the oil and gas sector part of the solution or part of the problem? They will tell you that it is part of the problem. And the challenge in the development of technology in this sector is how do you change that negative perception of the industry as being part of the problem to becoming part of the solution to the future, and how we continue to be able to access hydrocarbons in a way that we need even post 2045 and 2050. And technology will have to play a critical role in supporting that transition. That's why we part fund the Technology Centre in Aberdeen, helping to develop some of these new technologies that can be utilised within the industry as it goes forward. But we are nowhere near where we need to be at in order to meet that full challenge. And that's why your summit plays such, I think, a pivotal role in helping to shape the future in so many different ways. Many people think that when it comes to things like COP26, and this is my first COP event, but there's obviously been, 25 have gone forward previously, is that the change will really take place from the negotiations that's occurring within the negotiation room. And that this is a problem which will be solved and resolved by politicians and world leaders getting together today, which is very important, and we need to hope that they can be ambitious enough in order to help to support the transition that we're looking for. The mood music's not great, going from what happened at the G20, but people often think that that's where the solutions will come from. The reality is the solutions will actually come from the people that are in this room and who are listening online, helping to develop the technology that will be able to be deployed to create a net zero society. So the discussions that you have over the course of the next 3 days and beyond are critical to helping to support and achieve the outcomes that we are looking to get from COP26, just over a mile away from where you are today. It won't be the politicians that will develop the technology. It won't be the politicians that will be able to resolve the full pathway to becoming net zero. It will be the skills and expertise of those within industry who can develop the technology that achieves that. And that is why your role, in my view, is so mission critical in supporting a just transition for the oil and gas sector, and how that can benefit the wider energy sector and wider society going forward. So I hope over the course of your discussions in the days ahead that you recognise the importance of your role, that it's not just about developing technology for technology's sake, but it's also about helping to support what we often refer to as the just transition, supporting those who are in the oil and gas industry just now to be able to remain there, or through the use of new technology, or being able to move into new areas of technology and can be deployed in other parts of the energy network. All of that, and the role that you have in shaping the technology, will be absolutely crucial in developing and setting that course. So I, from the Scottish Government's perspective, I'm delighted that the Net Zero Technology Centre is hosting this summit. I'm delighted that it has such international interest in the collaboration across 10 different countries. If it's difficult to get agreement between 190 odd different countries, I'm sure you can crack it with 10. So no ifs and no buts. But I'm delighted that you've been able to develop that collaboration, because the reality is it will be collective effort. Collective thinking, shared understanding, cooperation, which will deliver the challenges around technology that we will need for the future. Not just to harness them here in Scotland, but so that they can help globally the transition to becoming net zero and averting the climate catastrophe and the biodiversity loss which we are facing as a result of the pathway which we are on at the present time. So I wish you well during the course of the summit. I will eagerly await the outcome to hear more about some of the developments that start to progress from this in itself, because all of these events must have a purpose to them, and the purpose must be to start the technology and development of technology that can help us on our pathway. So I wish you well. I look forward to hearing the outcome from the summit, and I will watch on with interest in hearing how some of the thoughts that are generated during the course of this summit start to become a reality in the next couple of years. And And I say the next couple of years deliberately because we do not have time to waste. This is a journey that needs pace injected into it if we're to meet this challenge, and technology is one of the areas where we need to see faster pace in development. So thank you very much for your time, and I wish you well with the rest of your summit. Thank you very much.
Many thanks, Cabinet Secretary. I really don't know what to add, and I won't add anything, but your words of encouragement and your sense of urgency is well received. And I think I'll take on that by not wasting any further word and urgently moving to the action of today. And so I'd like to welcome our first technology center to speak. And you will not be surprised that we start from Scotland. And we start with the Net Zero Technology Center. So I'm pleased to welcome Martin Tulloch, who is heading our Energy System Integration Program. And he's also been a co-author of a report towards last year about integrated energy vision for the North Sea. And he's going to tell us all about that vision and what technology are needed to achieve it. Martin.
Great, thanks Luca, and hello everybody. As Luca said, I'm Martin Tulloch. It's my privilege to lead the Energy System Integration team at the Net Zero Technology Centre. And over the next 10 minutes, I'm going to introduce you to two flagship reports that we published. The first one, Closing the Gap, is technology focused. And the second one, the Integrated Energy Vision, is one that we prepared in partnership with the Offshore Renewable Energy Catapult on behalf of a broad group of industry stakeholders. So let's start by taking a look at the picture today. This is UK energy demand, electricity and overall energy. So let's start on the left. At the moment, we produce and consume just over 300 terawatt hours of electricity in the UK. So you've got renewables in green, gas in blue, nuclear in yellow. At the same time, if you look at the total energy demand, so electricity plus transport fuels and heating and industrial processes, we've got over 1,600 terawatt hours of demand. You see in the image to the right, the sheer scale of hydrocarbon dependency at the moment. Oil in red, gas in blue. And to get to net zero, this is a journey that we need to go on over the next 3 decades. So the scenario I present here is taken from the Climate Change Committee. It's their further ambition scenario. And when we undertook this research back in the early 2020, this was the most up-to-date scenario. Now, since then, of course, the 6th carbon budget's been published, and that introduces 4 pathways to get to net zero by 2050. But still, the further ambition is quite a central scenario just to illustrate the journey. So if we look at electricity first on the left, we need to more than double the amount of electricity that we produce and consume as a country over the next 3 decades. That's going to have to be low carbon electricity. So in the UK, offshore wind's got a pivotal role to play there. But also look at the blue gas power. We need as much gas power in 2050 as we currently use today to balance intermittent renewables, according to the Climate Change Committee. That's going to have to be clean gas, so either gas with carbon capture and storage or using low carbon hydrogen as a fuel. Look at the overall power demand. Again, a slight decrease there due to efficiency gains, but a huge phase out of oil. Again, the further ambition scenario has gas playing quite a significant role because it's quite heavily reliant on blue hydrogen. Now, the 4 scenarios in the 6th carbon budget all have a larger reliance on green hydrogen from offshore wind. And coincidentally, the 3 scenarios in our document also have the same focus. I'll introduce those in a couple of minutes. Along the bottom, you've got a snapshot of the fantastic resource we've got at our disposal. So in the UK, we've got between 95 and 250 gigawatts of deployable offshore wind. We've also got 100 gigawatts of waiver tidal potential, a little bit less mature technologically. Surprisingly large solar power reserves, again, predominantly domestic solar, significant oil and gas reserves, and huge potential for both blue and, more importantly, green hydrogen production from that offshore wind base. Plus, we've got the infrastructure and the subsurface geology to enable us to store huge quantities of carbon in the subsurface. Now, I've taken some images from the Closing the Gap report to try and give a pictorial sense of the journey we're going to take over the next 3 decades. So this image here should be quite familiar to everyone in the room and those online. It shows an offshore sector dominated by oil and gas infrastructure, but with a significant and growing fixed and now floating offshore wind presence. Fast forward 15 years, and things really have to change. We need to get 40 gigawatts of offshore wind by 2030 to meet the offshore wind sectorial target. So you start to see oil and gas assets being decommissioned, some of them repurposed for carbon storage, some potentially for floating wind substations, but much greater integration between the two industries, both in terms of infrastructure, workforce and technology. And fast forward another decade and a half to 2050, and we need a truly integrated offshore basin. So we need huge quantities of offshore wind. We need to be importing carbon to store from Europe, potentially exporting hydrogen to Europe and beyond, producing low-carbon hydrogen onshore, possibly offshore, and creating hundreds of thousands of jobs. So looking in more detail at the data, this is from our Integrated Energy Vision report. So I'll start on the left-hand side with a picture today in purple. So at the moment, we've got an offshore energy sector that supports 140,000 jobs, both direct and indirect. It contributes £40 billion to the economy, a combination of taxes, expenditure, and direct jobs. But we're 45% reliant on imports in the energy mix as a country. Now, the three scenarios we've developed all get us to net zero in 2050, but they each come with differing benefits in terms of jobs, import dependency, and economic impact. So starting with the first on the left, emerging. This is closely aligned to further ambition, so we see 70 gigawatts of offshore wind deployed by 2050. We see a decrease in jobs as the oil and gas industry matures and the industries that are replacing it are less labour intensive. We do see significant economic impact because of the vast capital expenditure to get the infrastructure that we need. But we remain heavily reliant on imports. So moving one further to the right, progressive. In the progressive scenario, we see the deployment of 100 gigawatts of offshore wind. Now that's about the same level as the Climate Change Committee currently has as a minimum for 2050 in the 6th carbon budget. We see an increase in the number of jobs to 158,000, and we see our import dependency decrease to 30%. But move to the one furthest on the right, transformational. In this one, we envisage 150 gigawatts of offshore wind deployed. We see a huge decrease in our import dependency and a huge increase in economic import and jobs across the supply chain. So this is a truly transformational scenario that sees the UK become a net exporter of energy by 2050 and beyond. All that's underpinned by technology. To get to net zero, we need to develop effective and efficient technologies to make the journey as pain-free as possible. So on this slide, my final slide, I've just highlighted some of the technologies that form part of our roadmap at the Net Zero Technology Centre. So quickly, starting from the left, in oil and gas, we need to develop technology to allow electrification of offshore assets, to enable methane emissions to be reduced, to enable fuels, low-carbon fuels, to be used in existing gas turbines and internal combustion engines offshore. That's going to be essential to maintain our licence to operate. Alongside that, in offshore wind, we need to drastically reduce the cost of floating wind by reducing the weight, by innovating in the manufacturing process. At the same time, we need to address technical challenges like ensuring the robustness and reliability of cable connections to floating wind. In carbon capture and storage, we need to increase the efficiency of existing carbon capture technology. We need to develop direct air capture, potentially direct seawater capture technology. And there's a whole host of infrastructure challenges as well. Subsurface safety valves, metering solutions, subsurface measuring and monitoring technologies. And finally, on the right, in the hydrogen space, again, we need to make existing hydrogen generation technology more efficient by reducing the cost of membranes and catalysts, by reducing the cost of desalination, but at the same time looking at those disruptive technologies like solid oxide electrolysis, plasma gasification, and also investigating the role that the subsurface can play in allowing long-duration energy storage, which is a real niche for Scotland at the moment. So that's a quick overview of the technologies. These technologies will have to be deployed globally. Climate change is the biggest challenge that we'll face in our lifetimes as a planet. As the Cabinet Secretary said, it's absolutely essential that we work together to address this challenge. And that's why it's so exciting and so invigorating to be here as part of this 10 technology organisation group, We need to be able to deploy these technologies at scale and at pace, and we can only do that by working together. So I'd like to finish by pointing out that you can download both those reports from our website free of charge. I'd like to say a big thank you to my colleague Jason Patterson, who was our lead author on the Integrated Energy Vision. He also prepared the slide deck and should have been presenting, but he couldn't make it today, unfortunately. And finally, a big thank you to everybody who's here in person and everyone who's joined online for taking the time to be part of this. Thanks.
Excellent. And thank you, Martin, for breaking the ice as well and started this journey around the world and towards net zero. And for our next speaker, we're crossing the Atlantic and landing on the east coast of Canada. And I'm pleased to welcome Metzi Prince. She is the Project Delivery Manager at the Energy Research and Innovation, Newfoundland and Labrador. Metzi, we look forward to hear your views from Canada.
My name is Metzi Prince, and I'm delighted to be presenting here at COP26 on reducing emission in Newfoundland and Labrador's offshore oil and gas sector. Before I begin, I would like to acknowledge the land from which I am speaking as the ancestral homeland of the Beothuk and the unceded traditional territory of the Beothuk and the Mi'kmaq. I also acknowledge Labrador as the traditional and ancestral homelands of the Innu of Nitassinan, the Inuit of Nunatsiavut, and the Inuit of Nunatukavut. As First Peoples have done since time immemorial, we strive to be responsible stewards of the land and to respect the cultures, ceremonies, and traditions of all who call it home. Today, I'm going to give a brief overview of who we are, the Newfoundland and Labrador offshore, our challenges, our project portfolio, and next steps. Energy Research and Innovation Newfoundland and Labrador is federally incorporated not-for-profit organization, formerly Petroleum Research. We facilitate research and innovation for the local oil and gas industry, and we collaborate with research organizations nationally and internationally. You most likely know all our members, which represent the local oil and gas operators, but one you may not know is OilCo, and they are the Government of Newfoundland and Labrador's Crown Corporation for oil and gas activities in our province. Before I go into more detail on our project portfolio, I would like to give you an appreciation for our Newfoundland and Labrador offshore landscape. We are the most easterly province in Canada, and we have 4 operating assets, as these dots on the map represent, approximately 350 kilometers east of St. John's, in relatively shallow water, approximately 100 meters in depth. In addition, we have a potentially new development, approximately 500 kilometers offshore in deeper water. Hibernia and Hebron are gravity-based structures, while Terra Nova and Sea Rose are FPSOs. We are not considered Arctic, but our region is considered a harsh environment with unique operating challenges, especially ice conditions and the distance from shore of our operating assets. This potentially affects the feasibility of using renewable energy to power our offshore. Icebergs scouring the seabed can interfere with cables and pipelines from shore, and pack ice can interfere with the use of floating wind turbines, for example. How do we stand on greenhouse gas emissions? Our offshore oil and gas is about 30% below global average for carbon intensity, making it among some of the least carbon intense oil in the world. Within Canada, our offshore emissions are less than 2 million tons, which represent approximately 1/4% of Canada's total emissions from all sources. We were asked by the Government of Canada in 2020 to manage a $33 million research, development, and demonstration portion of the Emission Reduction Fund, with the objective to reduce greenhouse gas emissions in our offshore oil and gas industry by driving innovation in emissions management technology. We developed a framework to describe and illustrate the portfolio of projects selected for the program. Our goal was to deliver a diverse and comprehensive portfolio that addresses near to long-term reduction and also supports industry 2030 and 2050 targets. We used 3 categories for projects based on the nature of greenhouse gas reduction realized and the method in which it would be achieved. On the left, you can see Operational optimization. This is for projects which use efficiencies to reduce emissions without the need of major modifications. Design, innovation, and technology demonstration is where potential retrofit projects that implement novel equipment or new technology will fall. And for these categories in the framework, we also group projects by the main sources of greenhouse gas emissions listed across the top. The last category on the left is net zero pathway. This really represents a balanced carbon mitigation portfolio, and this includes initiatives to advance towards a net zero future, including enablers to the oil and gas industry's energy transition. And these are our projects. As you can see, we have a diverse portfolio in all three categories and addressing the four main sources of greenhouse gas emissions. Some of these projects are proprietary or fill in a knowledge gap for our local industry, so I won't be discussing these projects here today. However, you can visit our website at erinl.ca to find out more. I will touch on the remaining projects, which are moving to technology readiness level and could be applicable to other jurisdictions. So our first project, Synergreen has developed a patent-pending nanoparticle stabilized foam technology called Synerfoam that increases the reservoir's ability to store gas and thereby reducing gas compression requirements. Luminate is a novel downhole pressure monitoring system that provides real-time measurement about downhole conditions during the various phases of drilling. This will optimize wellbore operations, removing uncertainty, and reduce the time required to construct and work over wells. Suncor, in partnership with Copsys, is developing an intelligent digital skin, which is a new coating-based, like paint, digital sensor technology that could transform existing corrosion and integrity management systems. The project aims to advance this technology to manage corrosion under installation and thereby reducing piping inspection frequency. This technology will indirectly reduce emissions from all four of the main sources. Water for Energy Services, in partnership with SciTech, are studying the feasibility of using floating wind energy to power offshore assets such as mobile offshore drilling units. The project plans to use these units as a test case to identify technology gaps associated with real-world use of floating wind power for offshore assets. Duction Motors will develop the world's first 400 kilowatt hybrid diesel-electric propulsion system that can be retrofitted to in-service offshore vessels without the need for dry docking or significant drive shaft modifications. Atlantic Towing is demonstrating a first-in-kind integration of multiple battery technologies and will integrate spinning reserve and all-electric transit on an offshore supply vessel. The project aims to combine these technologies together under one single power management system, while also enabling future technologies such as hydrogen fuel cells to be easily integrated into the system in a later date. MA ProSense is building a prototype compact system for carbon capture for power generation systems, including gas turbines and steam generation systems. The proposed system addresses the weight and space restriction challenges of offshore installations. Memorial University is researching the use of metal organic frameworks to sequester carbon dioxide from offshore oil and gas exhaust streams. These frameworks are porous and can be designed at the atomic level for different applications. The project will develop a small-scale filtration system capable of being scaled up to real-world offshore applications. And finally, Planetary Hydrogen will research the potential to apply its carbon capture and storage technology to offshore oil and gas facilities. If successful, the technology could reduce emissions from offshore production facilities and store carbon in the ocean as harmless bicarbonate. So where are our gaps and our next steps? We are looking at carbon capture, but we also need to look at utilization, transportation, and storage. In the area of renewable energy, we have projects studying both wind and greenfield electrification of the offshore, but these are at the study level and we anticipate future work and technology advancement in this area. Hydrogen as a new value stream is a key area for Canada. And we have one study on blue hydrogen, but more work is needed on green hydrogen potential and technology advancements and infrastructure. Finally, in digitalization, this is a key area we wish to advance towards the goal of remote operation and automation. We have recently launched a major digitalization initiative that will also support emission reduction efforts. For energy research and innovation, we look forward to the successful outcomes of our current projects, and we will continue to work with and on behalf of our members and with our networks to advance road mapping and new innovation and technology opportunities. And that concludes my presentation. I'd like to say thank you, everyone. And once again, our website is erinl.ca.
And thank you very much to Messi. And just a note and a reminder for the people online that you can start submitting your question using Slido. If you're on Hopin, it should be on the right-hand side of your screen. And for the people in the room or those are following us on LinkedIn as well, you can do by logging into slido.com and using hashtag NZTC, as in Net Zero Technology Center 2021. Hashtag Net Zero Technology Center, or hashtag NZTC 2021. And you can start asking the question. We will pick them up during the panel at the end of the presentation. And our next speaker, next presenter, is still from Canada. We're just moving a little bit inland and a little bit west. And he's actually from the area of the tar sands in Alberta. So I'm pleased to welcome John Van Ham. He's the Executive Director at InnoTech Alberta.
Hi everyone, my name is John Van Ham and I work for InnoTech Alberta, a subsidiary of Alberta Innovates. And I've spent most of my career in energy and environment and innovation and technology, many years in the natural resource sectors, both in industry and also working with government and regulators. And now with one of Canada's premier research and technology organizations. And I'm speaking to you from Calgary, Alberta, in the heart of Canada's energy sector, where we're working directly on this topic of technology-driven transition. And before I get started, I just want to thank the Net Zero Technology Center for this event, for putting it on, and for starting a discussion on net zero oil and gas. And unfortunately, as you can see, we're at home today, but we hope to see you all soon, next year, in fact, when some of these organizations may also be discussing similar topics. More to come on that later in the week. So I just want to start by saying I'm going to emphasize a few points in my remarks today as we discuss the challenge and the opportunity related to net zero for conventional energy sectors. And I'm really going to focus on four things to keep in mind. Net zero requires taking the long view to the challenge. To achieve net zero, we will need many solutions. There is no silver bullet solution to this challenge. And in our planning related to net zero, we should maximize synergies with existing energy systems and maintain that value of the investments that have already been made to date. And finally, I'm really excited to get on with this together with all of you. And I look forward to the role that InnoTech can play in this panel and in working with the NZTC going forward. My first point around net zero means taking the long view. Net zero by 2050 goals are being set around the world with interim targets for the 2030s and 40s. And this summer at home where I live, the federal government of Canada passed into law the Canadian Net Zero Accountability Act, which aligns with 140 plus national commitments to date, several of which are also backed by laws. And to achieve this will require an enormous investment in energy systems, as we all know. Infrastructure that is extremely long-lived, with lifespans of a decade or two at minimum, and up to 40 plus years for large industrial facilities. And the International Energy Agency estimates a radical change to energy investment to enable this, with while recent years have hovered around $2 trillion US annually invested in energy infrastructure around the world, an additional 3 trillion per year is needed for net zero. So that's a 150% increase from the existing baseline today. And these policy timeframes, the size of the investment, the infrastructure longevity, it just foretells the need for collaboration and long-term planning, and therefore taking the long view. My second point around net zero is that it's going to take many solutions. So at InnoTech, we're seeing novel greenfield energy projects with new energy technology and products that are being developed. Some of them are fairly nascent and aren't yet really available commercially through liquid markets. There's lots of potential, but some uncertainties, technical uncertainties, still need to be worked out in some cases. We're also seeing new clean technology from existing facilities to help with the existing infrastructure, and from which products are being sold today into very large and mature markets. But the environmental, social, and government's expectations are starting to challenge those existing business models and market valuations. We're all seeing that. So this year, InnoTech celebrates its 100th year as a research and technology organization. We're all very proud of that. And so that's a century of innovation. And we continue to work every day on technology and processes that, if proven at the larger scale, will compete with existing and greenfield systems or complement existing and greenfield systems. Many solution pathways are being pursued. This is a good thing. Net zero is less than 30 years away, and so it's going to need a multitude of solutions across all components of the energy value chain, all the way from primary production to molecule transformation to transportation and end use. And that really brings me to my third point around maximizing the use of existing infrastructure. One thing we're certainly learning is that transforming to net zero from within an existing energy system, it has some advantages. And that's why we're really focusing on leveraging the synergies between the existing and the new. And we see a lot of opportunity for changing how we extract, process, and use hydrocarbons. So we're starting with working on near zero hydrocarbon recovery technology, non-thermal techniques that reduce water and energy use significantly via the use of solvents and alternate energy schemes. We're working on bitumen beyond combustion, so converting heavy hydrocarbon molecules into value-added carbon-based products. Instead of burning it for energy, we're working on spinning carbon fiber from asphaltene here in Alberta for use in industrial and consumer products, such as aggregates, composites, and other advanced materials. We're working on methane pyrolysis and other clean hydrogen technology. Alberta is actually the 10th largest producer of hydrogen in the world, so the province itself ranks that high. And we're working very hard to continue with clean hydrogen and to sustain that spot for us. Carbon capture use and storage is something we've been working on for many years here in Western Canada, and we now have several CCS and enhanced oil recovery projects, each storing millions of tons annually underground. And we're also working on the CCU part, so we're at the leading edge of carbon tech, the technology that converts or directly uses the carbon dioxide in end products. We recently hosted the Carbon X Prize Challenge in Calgary at the Alberta Carbon Conversion Technology Centre, where a handful of clean tech companies competed from around the world, 4 of which now sell commercial products made from CO2. An example here is some hand sanitizer from a company that's producing alcohols and chemical products for consumer use and for industrial end uses. The Carbon Conversion Center continues as a test center going forward for carbon capture and use research and development, and will also be installing and hosting methane decarbonization work at that same location. So just imagine a mini industrial complex focused on R&D on the synergies between methane, hydrogen, carbon, electricity, and water, all in one place. It's a pretty fun place to be. So this last point speaks to our focus on advanced materials and chemicals, and I'll also highlight our advanced manufacturing work that we're doing, which is enabled by these new materials and by this new chemistry. And the last few things I'm going to mention are work on energy asset decommissioning, closure, and repurposing. So this fits with net zero because of the focus on methane capture, so capturing vented or fugitive methane, and because of the work on repurposing of legacy sites for alternate uses such as geothermal, solar, or even hydrogen production. And the last thing I'll mention is a cross-cutting focus area on data digital and the industrial Internet of Things. We have a long history at InnoTech on chemical, physical, and biological sensors development and deployment, the actual hardware, the sensor development, along with the data capture, the analysis, and the machine learning. And all of these examples that I just provided to you in the last few minutes, they all have a role to play in net zero. So getting on with it together. To get to net zero by 2050, to best enable that 5 trillion per year investment that's going into energy infrastructure, we should be making the best use of our research and development capacity and capability of the research and technology centers represented on the panels today, tomorrow, and Wednesday. And these organizations should collaborate together. We're doing this in Western Canada with other partner research and technology organizations such as CFR Technology, CanMet Energy Labs, and various post-secondary universities and polytechnics. And we're also doing this through broader innovation networks in Canada, which include government and industry. So examples being the $100 billion Clean Resources Innovation Network, the $40 million Mining Innovation Commercialization Accelerator, and many other examples. And through working with panel members that I'm sharing the panel with today, we'll also be working on this together and sharing and learning globally. The intent of which is to advance technology together, focusing on what's being developed, which gaps still exist, and what's working and what's not. So while it's certainly a challenge, innovation organizations are laser focused on net zero energy products and services. In summary, it does require taking that long view. We will need many solutions to get there. There's no single silver bullet solution to this challenge. We should be maximizing synergies between future energy systems and the existing investments made to date. And I'm really excited to be getting on with this with all of you. We at InnoTech look forward to working with our fellow panelists on net zero oil and gas together. And with that, I just want to thank you all very much for taking the time, and I look forward to the panel discussion.
And thank you, John, and we all look forward to that panel discussion because as we start seeing, emerging some common themes and also some differences in the approach. One thing that has been mentioned so far a few times is carbon capture and storage. And so I'm glad that our next speaker is not about a region, it's about a technology. So we're going a bit south from Canada down to the Carbon Hub at Rice University. And I'm pleased to welcome Marie Contou-Carrère, who's a research advisor for industry partners at the Rice University Carbon Hub, who's going to talk about carbon utilization in the net zero world.
My name is Marie Contou-Carrère. I'm the interim executive director of the Carbon Hub, which is led by Professor Pasquale at Rice University. The Carbon Hub is a partnership between industry and academia, whose mission is to generate clean hydrogen energy while slashing CO2 emissions from industry and materials by fundamentally changing how we use hydrocarbons. So the world is faced with the dual energy challenge: how to meet the ever-increasing energy demand while meeting the targets set by the Paris Agreement and limiting our CO2 emissions. And this sustainability challenge is a little bit like a whack-a-mole problem. You think you may have a solution, but you may have created more problems. Hydrogen has the potential to significantly transform the global energy system. However, there are no natural sources of hydrogen. So an expanding color palette denotes the different pathways to produce hydrogen. But some of these pathways generate a waste stream of CO2 or solid carbon that has to be disposed of, while others require a lot of energy. At the same time, the primary CO2 emission offenders are manufacturing and transportation, which represent 43% and 25% of global emissions respectively. So in particular, decarbonizing the industrial sector is extremely difficult because making cement and metals such as steel requires a lot of energy from fossil fuels and also involves chemical reactions that emit CO2 as a byproduct. When it comes to decarbonizing the transportation sector, there are typically two pathways. One is to use lightweight materials such as aluminum and carbon fiber. The other one is to electrify the system. However, in the first case, you're introducing materials that have very large CO2 and energy footprint. In the second case, you introduce a lot of cables, so the weight of your transportation fleet goes up. And finally, the oil and gas demand is projected to peak in the next 5 years, but oil and gas represents 8% of the world economy. So is this a catch-22 situation? Is there anything we could do? Yes. Hydrocarbons can solve all these problems simultaneously, but don't burn them, split them into hydrogen and valuable carbon. So let's take a look at how we use hydrocarbons today. So the current world production of oil and gas is roughly 7 gigatons per year. More than, close to 100% of that production is burned to produce energy, which emits roughly 20 gigatons of CO2. But when you look at the carbon and the hydrogen, the hydrocarbons, really half of the energy is in the hydrogen. At the same time, there is intense pressure in renewables to not only displace the current use of fossil fuels, but also be able to provide additional capacity to meet this ever-increasing energy demand from the world. So the question then becomes, could we tap directly into the hydrogen energy from the hydrocarbons? And the answer is yes. Take your hydrocarbons, split them into carbon and hydrogen. And this splitting process does not emit any CO2. You can also use renewable energy for the energy you need for the splitting process. But the energy you need is a small fraction of the energy you recover as hydrogen. So if you start from methane, for every ton of hydrogen you produce, you also have 3 tons of solid carbon. Hydrogen is a commodity. So it doesn't matter which color from the palette it comes from. One molecule of hydrogen is the same as another one. However, carbon is a specialty product. There are different forms of solid carbon. Then the question becomes, what to do with the solid carbon? Well, you can use the right form of carbon to eliminate industrial CO2 emissions. This is where we're at. This is what can happen right now. Of course, the deployment of the sustainable pathways requires having the right efficiency, the right cost, and the right policies in place. So what do you do with this carbon? You have split your hydrocarbons into hydrogen and solid carbon without CO2 emission. Why is now the right time to look into this process? Well, recent technological developments that happened really in the last 2 decades have allowed scalable processes to new forms of solid carbon, such as carbon nanotubes and graphene. And these new materials, particularly carbon nanotubes, have properties that are similar to those of materials. They can compete with several materials such as metals because they have conductivity, strength, stiffness, all sorts of properties that are very helpful depending on the application you have in mind. So now we have these carbon-based materials that can be used in a wide range of applications, ranging from wires, beams, and panels for cars and industry to soil amendment for farming, opening markets that are tens of millions of tons every year. So now you have scalable processes that allow you to simultaneously harvest clean hydrogen energy while creating sustainable carbon materials with high use value and low environmental footprint. And this is already happening. In particular, carbon nanotubes provide a great footprint to enable this bold transformation in how we use hydrocarbons. There are several companies and labs across the world that are already able to produce these carbon-based materials. For instance, here in Texas, in Houston, we have Dexpat and Nanocomp, which already create films, ropes, fibers, tapes that are entirely carbon, that come from carbon that was obtained from splitting hydrocarbons. The world production of these carbon nanotubes, the most promising form of carbon nanotubes, is roughly 120 tons per year right now. And all of this has happened without any organized effort. And the most interesting fact is that for these carbon nanotubes, they have seen the rate of production go up and the cost decrease much faster than what has happened with solar cells. So we're not where solar cells were 40 years ago. We are where solar cells were 50 years ago. And this happened without any organization. So, of course, cross-sector collaborations are needed in order to increase efficiencies, decrease costs, establish new supply chains, which is why in 2019, Rice University established the Carbon Hub, which is a partnership between industry, academia, and federal labs. It was launched with a $10 million commitment by Shell, and we also have a national company joining us now with also $10 million commitment. So the Carbon Hub brings together the whole supply chain, from the oil and gas producers such as Chevron and Shell to the intermediates players that make shapes that will be useful for your end applications, such as Huntsman, to the end users of these materials, such as the Prysmian Group, which is a global leading manufacturer of cables. We have also established a vibrant research ecosystem with over 100 researchers in over 20 research organizations across 7 countries. This year, we anticipate that our research budget is going to be around $3 million. So in order to enable this bold transformation in how we use hydrocarbons, the Carbon Hub comprehensively articulates and coordinates 4 key activities. The Piazza is a community building arm that brings the scientific and engineering communities together. The Scuola is a workforce development arm. The Foro is a policy arm to ensure that policy development, societal needs and perceptions remain in sync. And the Bottega is a research arm. So the mission of the Carbon Hub, which is to generate affordable, sustainable, and reliable energy while slashing CO2 emissions from industry and transportation, mean that we're really well aligned with several of the Sustainable Development Goals by the United Nations. It's about producing clean energy, improving the efficiency of transportation, decarbonizing manufacturing and construction, and all of this without CO2 emissions coming from the hydrocarbons. I wanted to leave you with one of the projects we're supporting. So Dr. Mark Guthrop, an architect, is building a house entirely made out of carbon materials. He's receiving also significant funding from the US Department of Energy for this project. So don't hesitate to contact us at carbonhub@rice.edu, and I'm looking forward to answering your questions and discussing how you can participate and support the Carbon Hub. Thank you.
Thank you to the Carbon. Isn't that interesting? And adding another perspective, you see that how somehow complex and varied is the challenge, and also the range of solutions. So, but I'm not even trying to unpack it now. You know, we'll have some questions afterwards, and we'll go into much more detailed discussion on Wednesday, of course. But now let's stay in the US, and let's go to the last of our online speaker before we come back into the room. And the next speaker is James McCall, Energy and Environmental Analyst at the National Renewable Energy Laboratory, NREL, in Denver, Colorado.
Good morning, good afternoon, good evening, whatever the case may be. My name is Jeff Logan from the National Renewable Energy Laboratory, and I'm here today with my colleagues Jill Engelcox and James McCall to talk about the increasing use of renewable energy in the transition to zero carbon systems in North America. And what we're going to do today is give a series of snapshots of how renewable energy is increasingly being used in oil and gas operations in North America on the transition to a net zero future. One quick word about the National Renewable Energy Laboratory and JICEA. I think NREL, most people know that NREL is focused traditionally on energy efficiency and renewable energy, and JICEA is an institute within NREL that's a partnership between the 5 universities shown on the bottom of the screen here and NREL. And JICEA can work outside of the box of energy efficiency and renewable energy that NREL is traditionally confined to. And so what we're going to do today is, again, focus on North America. And here's a snapshot of the generation mix in both Canada on the left and the United States on the right. And we see that Canada is already very far along its path to reaching a net zero power sector. And in the United States, there's been a lot of change recently. In the past dozen years or so, coal generation has come down by over half, and natural gas generation has grown, and renewable generation has grown as well. The current US targets, I think, as everyone may know, is to have a decarbonized electricity sector by 2035 and a decarbonized economy by the year 2050. These targets will, of course, depend on legislation that is currently being debated in the US Congress. I just want to also mention some new methane regulations that are under development at the US Environmental Protection Agency. These new rules are expected to come out within the next week or two, and they will govern both new and, what's different here, is existing sources of oil and gas methane leaks. So one environmental NGO, the Clean Air Task Force, estimated that the new rules could reduce methane emissions by 22 to 65%, depending on the details. And some of those details have to do with whether or not they will be equally applied to small producers and large producers, and the degree to which aerial surveillance methods will be incorporated into the rules. Most large oil and gas companies in North America recognize the importance of social license to operate and the role that methane regulations play in that equation. So I'm going to now hand it over to my colleague, Jill Engelcox, who will give us some specific details.
Thanks, Jeff. And segueing from the social license to operate, the oil and gas companies in North America are starting to look at what their options are, both in terms of getting involved in other types of energy systems, as well as how to improve their operations to reduce emissions. So one of the things that we did at JC is we looked at where the resources are in North America, focusing on the lower 48 of the US. And you can see in this map that the yellow areas are where there is a high solar resource, the blue is where there's a high wind resource, and the green is where those combined. And then the gray areas are where we have significant oil and gas resources, and the red dots are refining capacity. And the key message here is that there's a tremendous amount of alignment between renewable resources and oil and gas resources. So considering how to transition the infrastructure, as well as to leverage the oil and gas companies who can access these different resources in these key regions of the United States, as well continuing north into Canada through the central part. So there's been a couple of cases that we've been looking at. If we go to the next slide, specifically looking at how we can look at electrification of well pads and oil and gas drilling and extraction. So this is using microgrid technology that we developed for remote communities and islands, looking at powering these oil and gas operations at the upstream through solar, through fuel cells, hydrogen, batteries, wind power, and then connecting these through a microgrid and a controller that will optimize these for both for cost as well as emissions reduction. And this could also potentially increase resiliency during power outages and make sure that you're able to provide these resources even if you are unable to receive electricity. So the other area we've been looking at is at gas compressor stations. If we go to the next slide. And compressor stations are important to transmitting the gas. And as Jeff noted, the power system in the United States is becoming increasingly dependent on natural gas. So it's important that these compressor stations, which are operated on grid electricity, very large amounts of grid electricity, are able to transmit that gas to the power stations. And so we've been looking at the options for using renewable energy technologies such as solar and wind and others at these sites. And our analysis found that it's very cost effective to have smaller PV sites at these locations. But if you add a carbon price, you can actually pretty significantly reduce their emissions at up to greater than 50% of the site load at a cost-effective rate. They currently have very low industrial electricity rates, so that you do need to have a small price of carbon to be able to overcome those industrial rates. And the final point here is that we feel that these compressor stations are going to continue to be important as we decarbonize the economy, because they will still need to be needed to transmit renewable natural gas, synthetic fuels, captured carbon, and hydrogen blends. So they're very essential to the transition to different types of clean power and clean fuel. So I'm now going to turn it over to my colleague James, who's going to talk a little bit about what's happening in California as an example.
Thanks, Jill. Yeah, we just wanted to talk real quick about California because we think it's going to kind of set a trend for other oil and gas operations within the United States. And those two trends that we're seeing is increased environmental regulations, both from carbon and methane and all the other air quality regulations, and also an impact from climate change on water resource and other resources that are used in the economy. So we're highlighting California because California has been operating under a carbon and cap trade system since 2006, or at least was established in 2006, and then have been updating their carbon regulations by going by 60% renewable energy by 2035, and there is some discussion about even going to 100% and then further decarbonizing the economy. At the same time, they have passed regulations looking into water reporting for oil and gas produced water to see if there's a way to mitigate drought and kind of the impact on that. So we have those regulations, but then that's also coupled with this job growth and tax income that is really important to a lot of these local communities. And so as we see at the top, the graph in the top left, we're still seeing an increase in oil and gas employment, but it's not increasing as much as other sectors in California, say, renewable energy or energy efficiency jobs. And that's going to have some impact on local communities and needs to kind of be balanced with the overall regulations. So oil and gas operators at this time are looking at innovative solutions to help with decarbonizing the economy. One of those is carbon capture and storage that is now allowed under state and federal regulations, and they're starting to permit some wells. We're looking at solar-powered steam generation and incorporating other renewables, such as the solar-powered or solar thermal project in the bottom right. We're also looking at water treatment for agriculture. And so Jeff, if you want to go to the next slide, we're seeing that there is this intersection with increasing drought and kind of regional concerns for increased water use from hydraulic fracturing. And particularly in West Texas, in Colorado, Wyoming, and parts of North Dakota, we're having this increased water use for hydraulic fracturing, and it's actually competing with other industries in agriculture. NREL is involved in the National Alliance for Water Innovation, and we are looking at what treatment methods and what ecotoxicity assays are actually needed to beneficially reuse produced water to mitigate this and basically just this further exacerbation of drought due to climate change. So that's all we wanted to talk about today. We look forward to continuing this discussion further on this week. We talked about some new trends in the United States in the energy sector. We talked about some solutions on the well pad and electrification for oil and gas operations. And then we talked about different environmental regulations in water within California. So thank you so much for your time.
Colleagues in the States, and I need to apologize because I introduced James only and forgot to introduce Jeff and Jill, but James is going to join us later for the Q&A, so that's where my mind got tricked, but thank you to all of them. Now, one of the things that came out, is clearly the transition from an energy perspective, but then the need while we have oil and gas to decarbonize the oil and gas production, and that is an industry. And oil and gas production is not the only industry which is hard to decarbonize. So I'm particularly pleased today to have also our last speaker for today in the room this time, and it's Professor Mercedes Maroto-Valer, who is the champion and the director of IDRIC, the Industrial Decarbonisation Research and Innovation Center. And he's going to talk about the importance and the technologies and the direction of decarbonizing industrial production, not just oil and gas. Mercedes.
So thank you very much. This is working, it's great. So I'm a 3D speaker, right? So we're going from 2D to 3D speakers. And I think I just want to start by saying thank you Congratulations, I think it's a fantastic summit. And if I can pick up on something the Cabinet Secretary said, that the role of technology being really critical, mission critical, I think what is also going to be critical is that we develop those solutions together. So I think, and I hope that's really the spirit in which we are doing this summit. So congratulations. One other thing before I forget, I would like to introduce a member of the audience, so I'm going to embarrass her, Dr. Anna Poulter. She's there. She's actually a member of the IDRIC team, and she's our expert in policy as well. So we'll be very happy as well to look in terms of policy questions. So it is technology, but policy goes really alongside. Okay. So let me see if perfect. So we are going to take a little bit of a UK perspective here, and within the UK perspective, I'm going to be focusing on industrial clusters. Some of you may maybe be very familiar. I can tell you I have read it cover to cover several times. This is the industrial strategy, Decarbonisation for the UK, published in March this year. And really, while all the strategies, what is really important here is that it gives us a path, it gives us a trajectory of what's going to happen. So it started from where we are now, 2021, and take us really in terms of that big picture of 2040 and 2030s and 2020s. And what you can see in there is that very soon, mid of 2020s, what we need to have is two carbon capture clusters. Those are really the red squares that you have. And then what we have is two more in the mid of the 2030s. And all this is going to be really critical for us to take us into our ambitions of being the world's first net zero cluster in the 2040s. And within that, as already has been pointed out as well, what is going to be really critical is the role of actually research and innovation. So we're really pleased in terms of seeing actually IDRIC being clearly mentioned in the industrial decarbonisation strategy. So as all the roadmaps start somewhere, actually with this roadmap where we study today, well, we started a few months ago, we actually started last year, but in terms of what is happening in this 2021, the way or one of the mechanisms to deliver that strategy is what we know the Industrial Decarbonisation Challenge in the UK. Gestation, this goes back to 2019, but really what we saw over in 2020, it was actually a lot of planning. And what we have moved into 2021 is what we call the phase 2, and that's the delivery of 3 actually complementary strands. The whole program has a value of around 210 million, and actually then is topped up with around 250 million pounds from companies and the private sector. And one of the things that makes me really excited here is that we have 3 elements of 3 strands of this activity. And it's not many times that you see this happening. I think this is where we can really make a huge impact in this space. So we have demonstrators, deployment projects, infrastructure, if you prefer to call them, and this is in the order of 170 millions. Then what we have is actually roadmaps or cluster plans, and this is of the order of 8 millions. And then what we have is an industrial decarbonisation research and innovation centre, IDRIC, of the value of 20 million. And the exciting here is that these 3 elements work together. Okay, so we are working together to understand, to learn from each other, to actually make sure that we develop skills, the knowledge exchange, and actually making sure that as we go forward, we can actually be more cost effective and we can actually accelerate the transition of the clusters. I'm not going to go into details in terms of the sectors that we cover, but you have there from chemicals, glass, paper, oil refining, iron, steel, ceramics, food and drink, really everything that is very energy intensive. And because they are energy intensive, traditionally these sectors have actually grouped, clustered each other. And they have clustered because in that way they could share infrastructure. And is that sharing of infrastructure what we are going to now take advantage in terms of deploying low carbon projects. So what we're going to see is these clusters attracting, and they're already doing that, what we call anchor projects. They are going to be attracting inward investment, and we're going to be building up from there. And this is really reflecting in also the 10-point plan that was published last year, the Powering Our Net Zero Future, and all this comes around the deployment of technologies. And really these clusters, as it says there, they're going to be at the forefront of technology development. And when I say technology here, we mean this in a really wide range. Everything from CCUS to hydrogen to actually energy efficiency, all these different technologies, a toolbox of solutions are going to be coming up from actually these clusters. So what is IDRIC doing here? I think we heard as well from the Cabinet Secretary, and I couldn't agree more. We have been doing well, but we are not doing enough, right? So we have to accelerate, we have to do more. And this is really where the role of IDRIC is key, because what IDRIC is set up is actually precisely to do that, is to accelerate the transition, to accelerate bringing solutions to the clusters. And these solutions that we work on, we group them into those 3 pillars. So if you look on your right-hand side, we have collaborations at scale and pace, and actually those words also came from the Cabinet Secretary. If you look on the left-hand side, we have solutions integrating technology, policy, business models. So what we're doing here is really having a whole systems approach, and that whole systems approach is not at the plant level or facility level, and it's not at the nation, UK, country level. Our whole systems approach is at the regional cluster level, because that's where our focus is. And key, and this has already been mentioned as well, is the skills. We talk about the energy transition, but let's not forget the energy transition is not going to happen if we don't have a skills transition going alongside. And we need to keep those 2 in mind. I'm not going to have time to actually unpack each of these 3 circles, so I thought what it was probably more appropriate is to unpack a little bit more around the solutions, because that's really what we are looking here around the technology development as part of this summit. And I would say also, I'm sure you saw the recently published the Net Zero strategy, and again, mentions IDRIC in terms of the initiatives that we are leading and being key in terms of being able to have or to translate our ambition into action. So one final slide here before I talk a bit more about technology is collaborations at the scale and pace. So who is IDRIC? Some of you may be wondering. So we have 142 partners. We are actually spread all over the UK, but also we have international partners. And we cover all those industrial clusters that you see there, from the Scottish cluster, Grangemouth and Aberdeen, going down to the Teesside, the Humber area, taking down into the Southampton cluster. And then as you go up through the West Coast, we have the South Wales, and then the North Wales with the Merseyside, Liverpool, Manchester area. 20 million have been received from the UK government, and then we have a match that with significant funds that we have captured from different partners. But the point I want to draw your attention here is actually over half of our partners are industry. Okay? So we are really doing research that industry-led. This is not just a group of academics that we are doing things that are only interesting. They are interesting, but they are also very impactful, and I think that's a big difference in terms of IDRIC. And in terms of impactful that I just mentioned, what we are doing is we map all our areas, all our activities to make sure there is an impact as those activities are happening. And that impact could be because we are reducing costs, as you have there, we reduce the timeline, the risk, we're reducing emissions, obviously, and also these economic and policy aspects that are critical. Because solutions are not going to be only technology-based. You will need to have a technology, you will need to have the policy, regulatory framework, and a business model to go on that. And that's what, for us, is a solution that we have brought to market. And in terms of the role of the technology, this was also coming from the industrial decarbonisation strategy. And we have mentioned the word innovation, we have mentioned the word technology. You can see very, very clear in here that the icon there, the light bulb moment, appears in multiple places. And in all those places where it appears is because we need innovation. We need to know a bit more about that technology before it actually can happen. We know what we are doing now. We are deploying. We have our infrastructure projects. That's the first wave, if you want to call it. But then, as you have in there, there is an uncertainty in the mix. So going from the 2030s, we don't have as a clear picture of what we are going to be deploying. And that's why the 2020s are so critical, that we do that now so actually we can have the full picture going forward into the 2030s. And in terms of how we do that, how do we make sure that we have the right mixture in our research and innovation program? I already mentioned before, the first thing for us is everything that we do has to be addressing an industry-led challenge. So we go through that exercise that you have in there, where we identify, we direct, we coordinate the research, we're making sure that we facilitate that industry alignment, and that alignment happens as we go through the project deployment. So following this, what we have is put together what we call our multidisciplinary integrated programs, or MIPS. And actually what this gives us is a portfolio, a toolbox of solutions. And I'm not going to go into detail through each of them. I'm sure Luca would not appreciate that I do that right now. But just really kind of the message to get here. This is about different technologies, but it's also how they integrate it together, how we can actually plan, how we can operate, how we scale up all these solutions. And really, again, goes back to the whole systems approach. And the final one, hopefully the messages that I convey to you, the urgency of what we are doing, is a need to do this at pace, to do it at scale, and critical for us is to do it together. Is the role of innovation that I already mentioned, the systems approach, and also how there is a space here for not only technology, but also skills and knowledge exchange. And I'm going to leave you with this slide here. We also have a small leaflet as well that we can actually either share with you or we can email it to you, and Anna has some copies as well. You can visit our website. There is what we call the first wave of projects that we have launched. We are soon going to be looking at opportunities for the second wave of projects, and really keen on talking with you together today or throughout the summit. Thank you very much.
Many thanks, Mercedes. And I'd like to thank you very much. And a round of applause for all of our speakers today. And I'd like, Mercedes, please stay on stage, and invite Martin as well to join for the panel. And if we can bring on the screen our other speakers as well for a few minutes of question and answer. I think we went a bit longer, my fault, but we still have time for a few questions. I think we also have Matteo Pasquale joining from the Carbon Hub in place of Marie. Thank you very much, Matteo. And so, I have a lot of questions here. We won't have the time to go through all of them, but you mentioned at scale, you mentioned at pace, and you mentioned together. So why don't we start from that? What is, you think, the advantage of us working together? What can we do together that we would not be able to do it individually? I don't know who wants to be the first.
I can maybe jump in there and give a perspective. I think a good example of why we need to work together is Bill Gates' latest white paper. He identifies 4 technologies, so long duration energy storage, green hydrogen, direct air capture, and also low carbon synthetic fuels. And their analysis shows that those 4 technologies need to be able to capture 7 gigatons of CO2 by 2050. Current trajectory, they're on target to do 1 gigaton. So that's about 2% of the world emits 50 gigatons per year. So that to me is an example, well researched, well presented, of why we need to do more than we're currently doing. The sort of benefits we get, if you look at all those 4 technologies, they're all part of our roadmap. They're part of a lot of the roadmaps that other technology centres were discussing today. So I think that there's so much common opportunity for us to work together on there.
Thank you, Martin. And anybody from our friends in North America want to add on that or have a different perspective? Matteo, can I come to you to make an introduction as well?
Sure. I think one of the main benefits of collaborating is that we're at a very early stage, and actually, if we talk and share ideas and early experiences, we may be able to weed out some of the pathways that are least likely to actually have a positive impact.
Thank you. John, I saw you about to step in.
Yeah, no problem. Thank you, Luca. Yeah, I agree with what Matteo just said. It's I think it's really important to work together because we can de-risk faster. I think we can learn from each other's experiences. We can share things that do work well, things that don't work well, and on the things that do work well and we're all working on them but independently, why not work on them together? And for the things that we're having challenges with, nothing like sharing those types of learnings with other people who are also having challenges in that certain area to help identify, is there a pathway through? Is there a breakthrough that we hadn't thought about before? By taking those different perspectives into account.
I can add something. I mean, I think that came quite a few times through my presentation, but if I can add something here, is we are running out of time. Okay, so I think we need to be clear. The 2050 target that starts today, or probably I would say that it started yesterday. So really what we need to do is to make sure that we cross-fertilize ideas, we do the knowledge exchange, everything that has been said, and it's only by doing that together that we are going to be able to meet targets. I think working in silos, we've been doing that in the past in some cases. I think we may get where we want to be, but it's going to take us longer. And I think it's clear that there's an urgency of a message of all the critical things we need to start deploying.
Thank you. And on that topic of urgency, if I can go to another question we got from the audience, if we challenge ourselves, could we make it net zero faster than 2050? And can I go to you, James, in California? Maybe what's the perception there? Can we get it before 2050?
I think that depends on, it depends on a lot of different factors, both from the technology development perspective, can we actually advance this kind of process, and kind of both from a couple different perspectives on can we decarbonize some hard to decarbonize sectors such as industrial or transportation, or can we electrify further systems and then kind of get a green, kind of very high penetration renewable kind of mix. And I think they kind of came out in the panel colleague from Newfoundland, making sure that kind of like the local kind of perspective is actually involved. And I think that also kind of goes back to the first question of what might work for someone, in one area doesn't work from someone in another. And so just kind of making sure that that is, the local kind of communities and the regional communities are involved in that process is going to be very important.
Anybody want to add anything? Maybe, Metsi, what's the perception in Newfoundland and Labrador?
I think that, I don't know if we can get to net zero faster, but we need technology, and technology takes time, both the research and the development and the demonstration. So working collaboratively definitely helps us get there faster.
Thank you. And if I can go to another question, which is actually directed to the UK, but I think it's valid globally, so I'll take the liberty to rephrase it. Lots of options presented, but can the panel answer the simple question? What is the lowest cost method to reach net zero? Anybody want to have a go at that?
I can go. I think in terms of, well, first maybe just making one small change to the question, if I may. I don't think it's a matter of what it's going to cost. I think we need to start making decisions of where we are going to be investing in technologies. And I think it's a huge difference when you talk about, particularly to governments, about this is an opportunity to invest on technologies for the future and for that transition. So I think we need to keep that in mind. I think it's not going to be one size fits all. The same as the 2050 target for some countries may be quite stretching, and for other ones we should really be looking at doing it earlier. And I think it's through that portfolio of solutions and options and roadmaps that we need to start deploying. But I think in terms of what is going to be the lowest cost or the lowest investment entry point, it's going to depend on where you are, even geographically within the UK. We don't have the same solutions if you are in Scotland that if you are in South Wales, to put an example. So I think we need to keep that in mind and not try just to force everything into one, and just keep all that toolbox of solutions going forward.
Yeah, I see a lot of nodding, and that is totally consistent with John was talking about, not a silver bullet, and the diversity of approaches around the globe. So we're getting close to the end, but can I ask each of the panelists to summarize in 1 minute, given this today is the day 2 officially of COP26, but basically the first practical day, and the next 2 weeks will be crucial for the future of the planet. What are your hopes? What are you hoping to see as an outcome from this COP26? Who wants to go first? Let's start from the Western, from James, James, can you go first? What do you hope to see from COP?
Yeah, I hope to see a pathway on how we kind of can leverage our current capabilities, and in particularly, from this panel's perspective on how do we leverage our oil and gas networks, both from our people, infrastructure, and everything, and how do we kind of take that and kind of create that pathway forward while kind of being inclusionary of all that, fully recognizing that there's going to be an urgency to get to net zero, but it's kind of how do we leverage these already existing pathways and make sure that that gets done in the most efficient way possible. So that's kind of what I would like to see.
Thank you. Matteo?
I hope we're going to see shared goals, shared targets are broadly shared across the world, although not everybody is at the table, as I understand. And I hope that these are goals in terms of where do we need to go rather than how to get there. I think that in the last year, some things have happened where people have jumped a little too fast on some technologies that could actually set us back by increasing the energy demand in a situation where we're trying to shift already from using fossil fuels as a source of energy. And so we may double or triple book the renewables that are coming online. So tell us the goals and not as much how to get there.
Thank you. Metzi, can I come to you next and then John to close the online panelists?
Yes, okay. Look, I don't know what else I have to add, but I think that any opportunity where you have like-minded people coming together, sharing their ideas, talking, we all have the same passion, sharing the ideas. If this inspires collaboration globally, I think that's very important, and so that we can pool our knowledge, pool our resources to attack this problem. It is the goal that I would like to see come out, and better working together. Collaboration is it.
John.
Yeah, thanks, Luca, and thanks, everyone. What I'm really looking forward to is the building on this consensus that seems to be building, and turning that into action. And as was mentioned earlier, action around setting what the goals are, and then turning it over to the STEM, the science, engineering, technical capabilities, along with industry, to identify the pathways to make that technological change happen. So really excited about this collaboration that's happening here, and playing our part to play that forward as much as we can.
Thank you very much. Mercedes, what do you want to see out of COP26?
I think we've been talking a lot about targets, and it's been a lot of deliberation. I think what we need is to move into the 2020s as the decade of action. And we have once in a generation, if not once in a lifetime, I would say, opportunity of making it right. And I think COP26, as it was mentioned before, with all the quite good number of countries, not all the players, but a good number of them. Here, I think that we really put those concrete plans on going forward, and we demonstrate that it's not just an ambition, it's really we are going to make this happen.
And to conclude in the room here, Martin, one hope for COP26?
For me, it's easy to look at for scapegoats. It's their fault, or the politicians should be doing more of X, Y, or Z. But to me, it's really crucial that we build on COP26. We don't see this as a one-off event. We see it at the start of a journey, and we don't just wait for every 2 years when we've got a COP and we meet. We need to work together across governments, across industries, across sectors to make sure we develop the technology to get to net zero. So that would be the key thing for me, is to make sure we continue this. We've got a lovely focus on COP26. The politicians are meeting 2 miles to the southwest of us here in Glasgow. We need to continue the work that they'll hopefully give us the framework to deliver against in 2 weeks' time.
Thank you. And so, on this note of collaboration and call to action, I think we have reached our time for the panel. There are a lot more questions, and we're going to answer them online. But we also take some of them into day 3, which is going to be all about panel and question and answer. It's been a fascinating journey around the world and around the different perspectives. And I hope you can join us tomorrow morning at 8 a.m. UK time for those online for the second part, and on Wednesday at 12 noon, still UK time, for the wrap-up and final considerations. I'd like to thank our speakers and panelists, both in the room and online. And also I'd like to thank the team behind that has been working to make all this going smoothly, but of course with a lot of legwork behind the scene that you haven't had the chance to see, but I do, and therefore thank you very much and appreciate. And finally, I would like to thank you, the audience, both in the room. It's been great to see a live audience again, and also the people that are following us, and I know there are many, on the live stream. And thank you for your questions, for your patience, and for your interest. And I hope to see you again all here tomorrow. Thank you.